203. Let's just check out our answers. Increasing or decreasing just means, is the graph going up or going down? And then I'm looking at -1 to 0 on the graph. So that's going down because you read your graph from left to right. So decreasing should have been your first answer. Let's see, from 0 to 2 on the graph, that's your x values. Now I'm talking about this section of the graph, and that's going back up, right? So you should have said increasing for part B. You always read the graph from left to right. Let's see, the x-intercepts. It looks like it has 3 of them. So one is at -1, one is at +2, and one is at 4. And if I write them as a coordinate, -1, 2, and 4 would all get zeros after them because the y value is 0. Let's see, the y-intercept. So now I'm on the y-axis. That would be at -4. Is that what you said? So 0, -4. Okay, when x is 3.5, another way I could write that is find f of 3.5. That's function notation. Let's see, where's 3.5? That looks like it's that high point, right? Is that what you said? 4? I would estimate 4. Let's see, so that is the maximum, right? The maximum y value is at 4. What is the minimum y value? What does this tell you right here? The minimum value, overall minimum, is at -infinity, it looks like. Does it go down forever and ever? So then it says, find the coordinates of a local min. So local mins happen where there's a, like it bottoms out. So that would be right here. Yeah, that's a local minimum. And then let's see, this would be considered a local maximum. This really isn't a maximum because it's going up, it's going up, it's still going up, it's still going up. So there's no maximum in here. So it looks like these are the two relative ones. So the coordinate for the local min, how would I write this? This is 0, -4 right there. Be very careful, x, y. And then local max would be at -1, 0. And I think from that eagle plotting points assignment, a lot of you are switching your x's and y's. So go back and fix that. Let's see, the domain and range. These are new terms, kind of this unit. Domain, you think of like you're opening up a window. So if I'm opening up a window on the x-axis, can my window just keep opening up? So these arrows are going down, but they're also pushing out a little bit, a little bit, a little bit. So I can open up that x window as far as I want. But what about on the y-axis? Can I open up my window as wide as I want? See how I'm stopped right here? So my window can keep going down, but my window stops right here. So you would write your domain as all real numbers, which we said was that boldface R, or you could write out the words all real numbers. But my range has to be less than or equal to 4. So I can't go below, or sorry, I can't go above that point on the graph. So we're going to keep practicing domain and range, but they go in alphabetical order just like x and y go in alphabetical order. All right, so that was the graph vocabulary. I want to skip back to page, the parent resource page. So I'll show you what that looks like. It's basically page 2, and it says all those parent functions. We're just going to draw a sketch. So it's like page 2 of your whole packet. And then this would be a resource that you can keep for the rest of the unit and for the rest of the year. You know, so if you're looking for what a linear function looks like, what a quadratic function looks like, it's important to know if something is acting linear versus if something is acting more exponential, right? When they were predicting the number of like virus outbreaks or the number of flu outbreaks, it'd be nice to know how the, you know, whatever it is going to behave. Or what about if you're looking for the population of a town, right? And you need to figure out how many schools you need. It'd be nice to be able to predict, you know, let's go to year 10 and see what the population is going to look like. And if you're using the wrong model, your prediction is going to be way off. What if your data is trending, you know, downward, right? If you're using the wrong model, your prediction will be way off. You don't want to be in a business and say, all right, we should go with advertising on Amazon because that's where it's at. And then you're wrong, right? You make the wrong prediction and Amazon's crashing and you should have gone with something else. So you need to know the correct model. So when you're looking at data, it's important to know, am I looking at quadratic data? Am I looking at cubic or square root data? These are probably new terms for you. So I just want you to be able to recognize what they look like. We know that linear data follows y equals mx plus b, right? Or just y equals x is the parent function, which is just a line through the origin with a slope of 1. We spent all last unit talking about linear data, but we haven't had to talk about the domain and range very much. So if I'm opening up that window with my hands, I can open it up from side to side, and I can also open it up from top to bottom. So all real numbers, all real numbers. I'm going to spend a whole unit on quadratic, talking about graphing quadratics. So that's when it is x squared. Does anyone know what the graph of x squared looks like? Describe its shape. You should know what this one looks like. This is the focus of our unit, this unit. This is a straight line. What does this look like? A quadratic. Oh, yes, yes. An upside down U or a right side up U, yes. So this is the parent function of the parabola. We're just going to put the upward facing one, but that one should be somewhat familiar to you. Like, oh yeah, I know that's a quadratic versus that's a linear function. It's domain and range. Still all real numbers. I can open up the window from left to right, but what about up and down? So the lowest I can go is where the vertex is sitting. So all my y values are above or equal to 0. Y is greater than or equal to 0. I can never graph down here unless I flip it over or transform it. We're going to look at transforming it this week. How do I transform these functions? Those are two biggies that you need to be able to graph by hand. These next two are kind of nice to be able to recognize, but I'm not going to have you graphing them by hand very much. So cubic is x cubed, and it looks like this. So as I'm graphing it, it goes up on the right and down on the left. And if you forget what it looks like, you can always make a table of values for yourself from like -2 up to +2. And all you do is you take the x value and you cube it. Do you know what cubing something means? It means multiplying it by itself 3 times. So like 0 times 0 times 0 is still 0. What would -2 times -2 times -2 equal? So 3 negatives would make a negative, but what's 2 times 2 times 2? Yeah, so that's why this is down here at -2, -8. What's -1 cubed? -1 times -1 times -1, still -1. So that's where this is coming from. And then 0, 0, because 0 cubed is 0. And then 1 cubed is 1, and 2 cubed is 8. So that's where these other points are coming from. See how it's like that S-shaped curve? So you don't have to graph that one by hand, but if there's cubic data, it might be nice to know that's cubic. You might also see cubic data looking like this. So a little bit more of a curve in the middle, just depending on what the rest of the function is doing. So you might see more of this straighter curve or like a really like couple bumps. Its domain and range is all real numbers. I can plug in whatever I want. It goes forever up and down as far as I want. All right, the square root function. The square root of x is the inverse of x squared from up top. So you're going to see some similarities between these two graphs. And to graph it, I'm going to show you a table of values. -1, 0, 1, 4, and 9. I'm going to pick a special set of values for this. Do you guys know what a perfect square is? 1, 4, and 9. What? Yeah, a perfect square is square with integer sides. So like 1 squared is 1, 2 squared is 4, 3 squared is 9. These are all perfect squares. So when I take their square root, they'll come out like integers. I can't take the square root of -1 though. I'll get an error. So there's a problem when I plug in negative values. But the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2, because 2 times 2 is 4. And the square root of 9 is 3, because 3 times 3 is 9. Some of you have taken geometry, right? So you did a lot with squares and Pythagorean triples and triangles. Can I take the square root of 2.5? Sure, I could take the square root of 2.5 on my calculator, but it's going to come out as like 1.32 something. I don't know what it is. I couldn't really guess. Let's see. Square root of 2.5. What do you think it is? What times what would give me 2.5? Oh, 1.58. So 1.58, if I did 1.58 times 1.58, I would get close to 2.5. But if I take just the square root of 9, I get 3, right? 3 times 3 is 9. And if I try to take the square root of -4, a negative number, it says that you can't do it. So when you graph these points, it's going to be sideways half of a parabola, because 0, 0, 1, 1, 4, 2, and 9, 3. Sideways half a parabola. Someone take a shot at its domain and range. Can I open that window from left to right as far as I want? X has to be what? Can I be -5? I could be 0. So X has to be greater than or equal to 0. And what about all the Y values? What do you notice in the Y column? Do you ever get any negative numbers over here? No. So Y is also going to come out as greater than or equal to 0. So just a quick show of hands. I already know linear is familiar to you. Quadratic, how many of you have graphed quadratic functions before? Show of hands. So you've had an introduction to quadratic. Show of hands, have you ever seen a cubic function before? Show of hands. Maybe an intro to it. What about square root graph? First time for that one, right? Maybe a little bit of an intro. Okay, that's what I assumed. I just want you to be able to spot these and say, oh, that's a square root graph, or that's a cubic graph. Maybe say the domain and range of the function. These points are going to become more important in pre-calculus. So if you're thinking about going on to that course, you'll learn how to graph these functions in a little bit more detail. All right, there's two that I just want to show you what they look like, but we're going to spend a whole unit graphing exponential graphs. So exponential increasing looks like this, and exponential decreasing looks like that. And it goes through at 0, 1, but we're going to learn more about those graphs later. And I'm just going to give you an example of like 2 to the x power versus 1/2 to the x power. If it's increasing, it's doubling or tripling the data, so it's going fast up. But if it's decreasing, it's like cutting the data in half. If you notice, the variable is in the exponent. That's what makes it exponential. See how the variable is sitting up here in the exponent spot? That's a superscript font. So it's not 2 times x. So y equals 2x versus y equals 2 raised to the x power versus y equals x squared. These are 3 very different functions. So if I gave you a matching, would you be able to tell me that this is the linear function, this is the exponential function, and this is the quadratic function? They all have a 2 and an x. So how confusing is that? So linear is the one that you've been looking at the whole time. That's the slope. Exponential is in the exponent. And then x squared is your quadratic, because you're squaring the number inside. So those 3, I think, are tough for students to keep track of. Domain and range on these, they can go side to side forever. See how my arrows are going side to side forever? So domain is all real numbers, but the range is greater than 0. There's actually something called an asymptote, which means your graph will never go below that line. We're going to study that in second quarter. Right now, I just want you to recognize that's an exponential curve, or that's an exponential equation, even if you can't graph it by hand yet. Okay, and then the last two, I feel like this is function soup right now, but our goal is to match the names with the functions with what the graph looks like, kind of putting that piece together this unit. Absolute value, we're going to graph this one by hand, this unit. So you're going to get really comfortable, hopefully, with graphing an absolute value function. So those bars is the distance that the number is from 0. And it ends up looking like a V-shaped graph through the origin. Have you seen this graph before? This may or may not have been introduced to you in Algebra 1. But the reason it's a V-shaped graph is because if you plug in a negative number or you plug in a positive number, you get out a positive answer. So it makes a negative number positive. So if I plug in -2, I'm at +2. If I plug in -1, I'm at +1. And then obviously positives just stay positive. So its domain is all real numbers, but its range is greater than or equal to 0. So if I'm opening up that window, my y values go up. And the last one I threw on here because I threw the cubic function in, so I figured I'd throw the cube root function in just so you could see it, even if we're not using it a lot this unit. Cube root has a little 3 right there outside of that square root symbol. So the cube root is a sideways cubic function. So see how that pairs up with your cubic function? We're going to talk about inverses later this year. So just so you can see, this was x cubed. This is the cube root function. Because the cube root of 8, if I go over here to 8, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So I wanted you to see that next to a square root and a quadratic. So a square root is half of the parabola sideways. So like these two go together as inverses, these two go together as inverses, just so you can see them that they exist. Like, wow, there's such thing as a cube root function, and that's what it looks like. Domain and range is all real numbers. You can go up forever or sideways forever. So those are 8 different functions that you're going to need to start thinking about and remembering. And we'll do some matching games where you've got to match the function, the equation, and the graph, just so you start wrapping your brain around those 8 things, because I know that's a lot of vocabulary, especially on a Monday morning. So see how much of that you grasped onto, and take a few minutes and check out page 202. You can use your notes. So there's a couple practice here where you identify, see up top, I've given you the graph and I've given you the name, and down below, I give you the equation. You have to tell me which graph it is and which name it is. So let's make sure we understand how to do this. Let's look at number 1 together first. X cubed. Which one of these up here is the x cubed graph? Who can find it up at the top? X cubed is which A, B, C, D, E, F, or G? Which one? It is B. So see down here at number 1, you're going to write that that is graph B, and that is the cube or cubic function, right? So that's N. So I've used up B for graph, and I've used up N for the type of function that it's called. Can you see if you can match, without looking back at your notes, the name and what it looks like? Do the couple that you know. Maybe do linear first. Do quadratic, and see if you can get those. X is exponential. That one looks like graph D, and exponential was L. Let's see, x squared is the parabola, so that looks like C, and I says quadratic. Let's see, x is linear, so yeah, I should have written linear. I'll have to change this for next year, but some books refer to it as the identity function, because y equals x, like 2 would equal 2, or 4 would equal 4. It's only the identity when it's this line through the origin, though, so it should have been graph A. The only one you had left was K, probably identity, linear. Let's see, this is cube root, so that was H and G, right? GH, graph and type. And then absolute value is the V-shaped graph. So that would be graph E and type J. So, I mean, it's a lot of terms and a lot of different graphs and a lot of domain and ranges. So I feel like if we kind of plant the seed Monday and practice it a little bit every day, you know, if you're here all week, by Friday, this stuff should be common vocabulary that we're using every day in here in this new unit. And last unit, you didn't have a lot of vocabulary. You had linear function or system of equations, right? That was it. Okay, so I think there is, I'm going to see if you can remember this in like 15 minutes. Could you take out the graphing page? Some of you finished already. It's page 201. So if you weren't here last time, we graphed the graphs on page 201. Some of you have a couple left to do, but just so everyone can see how to graph absolute value, can you turn to part 2 and start at graph 9? And then if you have time, we'll go back and do the quadratic ones as well. But for now, I want to show everybody how to do graph 9. So if you weren't here Friday, you can see how to do it. And I can show you how to enter the absolute value function. So we all need to have a calculator. Oh, someone in my class took a test and I collected them all. So I have to give them back. So everyone needs to have a graphing calculator. You want, all right, you want, you got one? Need one? Need one? Or is there one in your bin? Do you need one? Is there one in your bin? You got one? You got one? You got one? You need one? Is there one in your bin, Theodore? You need calculators? Let me order that over here. So let's see how to graph these. You need one? You need one? How will we find? You have one. You need one to graph with. Okay. Let's see if I have one more so I can. Okay. Compare, it shifted up 2 units, right? So I'm going to start up here and I'm going to show that my new graph shifted up 2 units and then go on to the next one. Always leave the parent function in y1 and just change y2, right? So try to finish up part 2. If you finish part 2 and you have some time, I'd like you to go back to part 1, or if you want to partner up and each of you do half of the graphs and then just compare your answers, that would work too. And we're going to talk about, well, what happened on these? How did they transform? So let's try the first one together. On the back of 202, what type of graph is number 1? Huh? What's its name? Is it linear, absolute value? This is the back of page 202. Linear, quadratic, cubic, square root. This is the quadratic, right? So I'm going to call it quadratic. You're naming the functions, but then you have to say their new domain and range. My domain is still all real numbers for this quadratic, right? I can still go side to side forever, but my range has changed because now I've flipped my quadratic upside down. What's the highest I could go on this quadratic? 4. So all my y values are less than or equal to 4. You see if you can name the function and do the new domain and range. And I'll give you a few minutes to